Hi guys, it's Mr. Robeson here. We're doing 8.2 today. We're starting to look at how to actually take hypothesis tests for proportions. We're going to start by just looking at how to check the conditions. All right, so first off, our conditions are very similar to what they were for confidence intervals. So we need to have a random sample because we want our p-hat to be unbiased. All right, we need it to be an unbiased estimator of the population parameter. We need to have that normal sampling distribution, approximately normal, except now we're not going to use p hat, we're going to use p naught, which is our starting p. So like this is our null hypothesis. In other words, the null hypothesis p. So we'll have p equal to something, p naught. That's what we're going to use because as far as we know, that's the actual p for the population. So we're going to use that when we're checking our normal conditions. And we also need our independence condition just like before, and needs to be less than 10% of the population, or it's satisfied if we're sampling without replacement, but usually we'll just write the n as less than 10% of the population because we need to be able to use the standard error formula. All right, so we'll be using, we'll go over this later, but it'll be p naught 1 minus p naught over the n square root of all that. Again, we'll go over that later, but that's why we have each of these conditions. All right, so here's an example. Mr. Robeson claimed that he makes 80% of his shots in Trashketball. You think he makes less than 80% of his shots. Less than. State your hypotheses. All right, so our null hypothesis would be, well, you just go with what I told you, that I make 80%. All right, whether you believe me or not, whether I'm trustworthy or not, that's what we're going to start out with. Our alternative hypothesis, HA, it specifically says less than, will be less than 80. And we should define our P here. It is the true proportion. But we should start with the words true proportion if we're working with P of shots Mr. Robeson makes. All right. So now in a random sample of 50 shots, he made 32. All right, so we've got our p hat is 32 out of 50, so that means our n is 50. So now we can check our conditions here. So first of all, it said random sample. So our first condition, we would say random sample stated. Notice I didn't just write the word random and put a check mark. I wrote the words random sample stated. That's what you need to write, guys. All right, next up, we're checking the normal conditions. So our P naught is up here. That's our P naught, 0.80. So our n is 50, so it would be 50 times 0.80 is 40, which is greater than or equal to 10. That checks out. And 50 times 1 minus 0.80 is actually equal to 10, but that works. Greater than or equal to, that works. So because of those two, we have an approximately normal sampling distribution. Notice I did not just write the word normal with a check mark. I wrote 4 words, and they are approximately normal sampling distribution. I abbreviated 2 of them, but I still wrote them. And finally, our sample size n is equal to 50, is surely less than 10% of all shots Mr. Robeson takes. All right, so as long as I could take more than 500 shots lifetime, then we do have independence met. Most of you were good on that one on the last test. All right, so there's checking conditions. Here's another example. So according to the U.S. Census Bureau, the proportion of students in high school who have a part-time job is 0.25. The administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than the national figure. She would like to carry out a test at the alpha equals 0.5% or 0.5 significance level. I don't know what that really means yet, but we'll find out later. The administrator selects a random sample of 200 students from the school and finds that 39 of them have a part-time job. So we're going to start with just our first 2 boxes, just like we did before. The first box is state. So we're going to state we're working with a proportion, and this would be the true proportion of, here it is, the proportion of students in high school who have a part-time job. Of students in high school, I'll abbreviate that, who have a part-time job. I guess there's a dash there. There we go. All right, so now we need to state what our hypotheses are because it's asking us to do a hypothesis test. It's given us the significance level. That means it's going to be a hypothesis test. So we always start out with P equals, and we're given that they think it's 25%, so 0.25. And now we're going to say, well, let's see, our person is testing, is it less than the national figure at their school? So is it less than 0.25? So there's our hypotheses. All right, if we want to write down more stuff here, we can. We can say that our p hat is 39 out of 200. That means this 200 here would be our n. It's just kind of a lazy way of writing it. All right, plan for the significance test by checking the conditions. All right, so we don't know the name yet. I haven't said what the name of it is yet. All right, but it is going to be a one sample. All right, we're working with p, so that means we're working with z. ZAPTAX still applies. So with z, and now we're doing a test instead of interval for p. That is what our test is called. We'll go over that more later. So let's see. The administrator selects a random sample. There it is right there. So we have random sample stated. Next up, let's see, the normal condition. So we want to do n times p. So our n is 200. Our p naught is our starting p right here, 0.25. So times 0.25 is 50, which is greater than or equal to 10. That checks out. And 200 times 1 minus 0.25 would be the rest of them. So 200 minus 50 is 150, which is also greater than or equal to 10. So we do have the normal condition met. So we have an approximately normal sampling distribution. Kind of abbreviated sampling there for a second. All right, so that's what we need in order to do this test, is we have to have this approximately normal distribution with our mean p hat would be the p naught, the 0.25, and that would be the middle of our sampling distribution. All right. And the last one we want to check is the independence condition. So we've got n equals 200. Hopefully that is less than 10% of high school students at their school. So hopefully we have 2,000 or more students at this school, which is possible if there's a large high school. All right, so that's how we check our conditions. So here's another one. Which condition is not met? So Mr. Robeson says he makes 80% of his shots in trash ball. You think the true proportion is different from 80%. You ask him to take a random sample of 20 shots, just 20 random shots from around the classroom. All right, so we'd start off with our null hypothesis is 0.80. Our alternative hypothesis would be, we're asking that it's different from, so that means it would be not equal to 0.80. Maybe I make more, who knows? Our n here is 20, right, and that's all we know. So let's see, it says we've got a random sample, so that's taken care of. That one checks out. N times p naught would be 20 times 0.80, which will be, what is that, 16? Which is greater than or equal to 10, that checks out. And how about the next one? 20 times 1 minus 0.80 is 4. That's a problem. So this is the one that is not met. And n equals 20 would probably be less than 10% of all shots that he takes. That's probably fine. I can take more than 200 shots. I can just sit around all day at school and just take shots. All right. So there it is. So that's how we check our conditions, and we did a little bit of practicing writing hypothesis. Next time we'll come back and we'll actually do the full test.